everyone. Today we are going to learn about solid mechanics. So previously this subject is called as strength of materials. Now the revised syllabus it will be named as a solid mechanics. So myself Dr. AP Tadmalle, Associate Professor from Sinhagad College of Engineering, Vadgaon. So we'll see the definition of solid mechanics. Solid mechanics is one of the important branches of the physical science concerned with the deformation and motion of continuous solid media under applied external loads, or this can also be um, defined as a it's a branch of continuum mechanics that studies the behavior of solid materials, especially their motion and deformation under the action of forces, temperatures, phase change, and other external or internal agents. In shortly, it can be defined as it's a branch of physical sciences. It deals with the bodies under applied loads and constraints. So thus the everyone has presented the definition in a different fashion. The first definition is represented so in a general way. Second definition is specific to the solid mechanics and it refers the continuum mechanics, and the last one is so it's a general in sense. Or so this can also be defined as solid mechanics is the study of deformation and motion of solid materials under the action of forces. It is one of the fundamental applied engineering sciences in the sense that it is used to describe, explain, and predict many of the physical phenomena around us. Here, there are some wide range of questions which solid mechanics tries to answer. So those are so one, it provides the answer about when these gears will be wear out and how do you build a bridge which will not collapse and which will provide the service to the nation for a longer period. And the most important and so the application from a different field, so that is a biomedical field. So the how the heart contacts and expands contracts and expand as it pumps. So this mechanism of this contraction and expansion is also studied with the help of solid mechanics. Also it provides the solution to the nature inspired objects, or the objects are made from a different materials such as leg bones and some skins, muscles. How does nature use the materials it does? So for this also we will get the answer from the solid mechanics. And the some devices were in operating conditions. So how long will the turning fork vibrates for? So for this also we will get the answer from solid mechanics. So this solid mechanics is one of the most important subject, and it also provide the solutions for many things such as glaciers, so moving objects. And the solid mechanics is a vast subject. One reason for this is a wide range of materials which falls under its ambit. For example, so steel, wood, foam, plastic, foodstuffs, textiles, concrete, biomedical materials, and so on. Any you take them any material, so that can be studied with the help of this solid mechanics. So another reason is the wide range of applications in which these materials occurs. For example, a hot metal being slowly forged during manufacture of an aircraft component so will behave very differently to that of an automobile which crashes into a wall at high speeds on a cold days. So it provides the answer to such things by solid mechanics, and here we will see some examples relevant to the examples of solid mechanics of a cold body, hot body, slow and fast moving objects. So here you can see, so it provides the answer to the objects like this. So how did the Antarctica ice fractures, and how much will this glacier move in one direction, and what materials can be withstand extreme heat. So for example of extreme heat is some rockets. So the rocket engine is operating at very high temperature around 5000 degrees centigrade. So the material which material which sustains at this higher temperature. So for that the answer will get from the solid mechanics. Similar way, the objects are moving with a very high speed and they will hit to a surface. So when it hits to a surface, what damage will occur during the crash? So for that also we will get the answer from solid mechanics. So these are the few examples so which are relevant to the very slow moving glaciers. We will move very slowly, and the fracture of ice and devices which are operating at very high temperature, and when the object are subjected to crash, so how it will behave here. And another category of objects, so here we can see, so there are some examples of solid mechanics of the small, very small objects, and there are very large objects, the objects which are fragile in nature, and the objects which are very strong. So we'll have some simple examples for this. So this is the example of a paper. Paper is constructed out of fibers. The fibers are arranged in different directions. If all fibers are arranged in the same direction, in that direction the fiber have a less strength, and transfers to that it has a more strength. So if you are arranging these fibers in a random direction, we will get the strength in both the directions. So thus the arrangement of fiber affects on the quality as well as strength. So that answer to such things can be provided by the solid mechanics. And also there are some objects which are fragile in nature. How strong is an egg cell, and what prevents it from the fracture? So this answer also will get from the solid mechanics. So this is a fragile in nature, and there are very large objects. So ship. So you might have seen the ships, so which have acres in length. The area covered by the ships is in terms of acres, 5 acres, 10 acres, 15 acres, and so on. So here, so always ships are subjected to slamming of the waves. So wave hits on the surface of the ship, and it will be subjected to heavy forces. In sometimes ship is moving with a speed of 30 to 100 kilometers per hour, as well as the waves will move from uh, waves have a speed of around 30 kilometer per hour to around 100, 200, sometimes it is 200 kilometers per hour. So with this speed they are moving in opposite direction. A huge amount of force is exerted on the ships. So what is the material and what is the strength required to sustain such heavy loads? So for that, so the solid mechanics provides the answer. Similarly, the we are constructing a damage dams for holding a huge amount of water in its catchment area. So for this also, so what may be the width we have to consider, dam length, and for this, so it provides the solid mechanics provide the answer. how thick should a dam to be withstand the water pressure. So these are the few examples which provides the significance of solid mechanics. The things around us, everything, it needs the knowledge of solid mechanics.